Here's our first example for substitution. Unlike graphing systems of equations, substitution allows for a greater width of answers. And what I mean by that is when you graph, you can only find nice, what we call lattice points, real integer solutions. And so when we go to the substitution, we can allow for fractions. Basically, these examples, I just want to get the point across on the method behind substitution. And so let us begin. When we look at the two equations, we want to look for a variable that's easy to isolate. As we look at these two equations, equation 1, equation 2, equation 1 already has y isolated. And so when I say y is equal to 2x plus 4, it means that anywhere I see y, I could plug in 2x plus 4. And so to use the substitution method, I jump to equation 2, and I simply rewrite it, except anywhere I see y, I'm going to replace it with 2x plus 4. As I replace it with 2x plus 4, notice what happens. This second equation, as I replaced the y value, ended up creating an equation that only had x's in it. Well, we've been solving those since day one, so this should be no trouble at all. I simplify this. I say 4x, I'm going to distribute, minus 6x minus 12 equals negative 13. Combine like terms, negative 2x minus 12 equal negative 13. I'll move that negative 12 over to the right-hand side. So we have negative 2x is equal to negative 13 plus 12. Negative 2x is equal to negative 1. Now as I solve this, I divide both sides by negative 2. I get a solution for x. I know that x is going to be positive 1/2. Keep in mind you are solving for a system of equations, so there are three outcomes. Either you can find one point of intersection, the lines are parallel, which means you wouldn't have any solution whatsoever, or the lines lie on top of one another, they coincide, and you have an infinite number of solutions. Since I was able to find an x value, that guarantees that I have a point of intersection. The x value is 1/2. To find the y value, what I love about substitution, you're always going to have somewhere a point where you have y equals something or x equals something. Once you have your answer, you can always plug that right in. It's a very quick substitution. In other words, you can do this in your head. 2 times 1/2 is 1. 1 plus 4 is 5. So I get my point of intersection, which is 1/2, 5. I would not be able to do that through traditional graphing techniques. I mean, I might be able to guess that it's 1/2, but I couldn't guarantee it. That's why the substitution method will be more powerful. That is example 1 for substitution.